Hello learners, welcome back to education program online with Miss Teacher Christine, taking you in mathematics for senior 3 and senior 4. So dear learners, we are still continuing with our same topic, that is algebra part B, algebra 2, that is algebra part B, which is binomial expression. And under binomial expression, we are looking at the two concepts of binomial expression, and one of the concepts is permutation. In our previous lesson, we defined what permutation is, and we also looked at what we mean by permutation in mathematics when we are arranging things. And then now we are moving to the part B of this permutation, which is solving problems in permutation. Sometimes in other books they say problem solving in permutation. So when we talk of problem solving in permutation, we are looking at what we call statements. They will give you a statement and they will ask you to think critically to find the answer, how to solve the equation, how to come out with a solution for it. For example, in this, when you are dealing with the problem solving in permutation, you are to use the formula. This is the simplest formula that you are to master under permutation. So the formula is, you say permutation, which is P raised to n base what? Base r, which is the same as n factorial over n minus r factorial. So dear learners, this is our formula where n is a number of elements. In short, we just say number of elements that you are going to arrange. And then R simply means number of times. Are we together? I hope in that level, once you are able to interpret a formula in mathematics, then it becomes very easy for you to apply it. So if we are dealing with any problem solving in permutation, the formula for permutation is P raised to n base what? Base r. Maybe let me add here something here, permutation, so that you should not forget. You say permutation equals to P raised to n base r, which is simplified as n factorial over n minus r factorial. That is for permutation, because mostly they will give you in short. And then they will ask you to simplify. So you will simplify using this formula, where we have said n. When you see n, it means the number of elements. How many elements have they given you? And then r simply means the number of times. How many times are you going to arrange those elements? Then let us go straight to apply our formula. Let us look at our example. How do we apply this formula, or how do we use the formula? They will simply say, example 1, we say, how many different words? How many different words how many different words can be formed. Can be formed. Can be formed. Can be formed from the 5 letters without repetition. From the 5 letters. From the 5 letters. From the 5 letters. And the 5 letters are, we have A, B, C, D, and E. So, dear learners, that is what we said. They said, how many different words of can be formed from the 5 letters. So here they have given us the 5 letters. So if they have given us the 5 letters, you are to look at what should I do in order for me to form the word. Because if we do arrangement, for example, for those who have been playing Ludo, you know what it means. And then chess, you know what it means. So you keep on rotating the objects or the elements until you win. So it is what is actually all about here. Use your common sense out to your logical mind to get out to get the out to the solution. So for this case, we simply look at how many elements are there. There are 5. They are what? They are 5. And then now, if there are 5 elements, that means the arrangement, there are 5 letters. Sometimes they may not even list, they will tell you the word that there are 5 letters. They will say how many different words can be formed from the following, or from the word, or from the given letters. So if it is like that, they have not specified for us the number of times that the arrangement is going to be done. Then you will automatically just go straight on your solution and say, my solution, I will have, how many elements are this? There are 5. That means my first position or first number of letter are, you say, number of letters are, number of letters are 5, equals to 5. And then now, how many operations I'm going to perform here? Then I'm going to make how many operations? The first operation will take the first operation will take 5, and then the second, but now the number of what? The times they have not mentioned. That means our number, our permutation here will be n factorial, which will be 5 factorial, and then you simply get 5 times what? Times 4 times 3 times 2, and then times 1. So for this case, if it is problem solving, you must get the answer. You get the product of the answer or the outcome after multiplying. So you say 24, 5 times 4, we get 20. 20 times 3, we get 60. 60 times 2, we get 120. And then 120 times 1, we get 120. So there will be 120 words that will be formed. 120 words that will be formed in that case. And then example 2 will be example 2 says, how many 3 digits? Example 2 says, how many 3 digits how many 3 digits can be of a natural number? Number can be formed. Can be formed. From a set of open bracket we have 2, 3, 7, 5, 1, close the bracket. So dear learners, look at that example. Look at example 2. Example 2 says that how many 3 digits can be formed from a set of natural numbers which are given us in the bracket here. So meaning that now you are to look at in your solution, you look at how many elements are there, and then how many times were the elements selected. Learners, come to your question here. Here they said 3 digits. 3 digits were formed, were selected from this set, because from the word here, from this, that means the 3 digits were picked from where? From the set here. That means our R is 3 times. The number was picked 3 times. 3 times. And then when you look at our set of elements, we find we have 1, 2, 3, 4, 5. There are 5 elements. There are 5 what? There are 5 elements in this case. We have 1, 2, 3, 4, 5. There is 1 missing, which is 6. So those are elements which are there. No matter the order is not well arranged. So you only count how many elements there are, 6. Then now you come and say it is the same as saying P raised to 6 and then base 3. So sometimes they will give you in that nature, and then now you'll automatically say P raised to n base r is the same as n factorial over n minus what? Minus r factorial. Where we have known the value of n and the value of r. Then now you do what? You substitute. So when we substitute here, we know that P is for permutation, and then n is the number of elements. So, and then here it becomes now 6 factorial out of what? Out of 6 factorial out of 6 minus 3. So we simply substitute our formula here, and then we have 6 factorial out of in 6 minus 3 factorial. 6 out of 6 minus 3 factorial. So then now 6 factorial will give us 6 factorial. When we simplify the numerator, the denominator here, we get 6 minus 3. All of this is under factorial. So when we subtract this, we get 3 factorial. So we get 3 factorial. Now from there, learners, you can be able to simplify now. Then now you come and say, therefore, 6 factorial over 3 factorial is the same as 6 by what? 5 by what? By 4 by 3. So, and then by 2, and then by 1. And then you also move 3 factorial, 3 by 2, and then by 1. So that now this will cancel, this will go, and then 3 will cancel. And then you remain 6. You are only remaining now with the 6 times 5 times 3, which will give us 100. This is 6 times 5 gives us 30. And then 30 times 4, not 3, sorry, it is 4 times 4 will give us 120. Then now you say there will be, therefore, p raised to 6 base 3 equals to 120 ways or 20 words. Or you say ways. So it varies. Any you can take it as either words or ways. So dear learners, that is how you apply the formula of permutation. And then look, sometimes you can be asked to do what? That maybe if the number, you have to read the question properly and then you understand. Have they given you the R? Have they given you the N? So if R is not given, then you simply means that you only list descend the number and then you get the product. But if R is given, then you have to apply the formula. So number next says a garden has 7 doors. Example 3 says a garden has 7 doors. A garden has 7 doors. In how many ways? In how many ways can a person enter through and come out from another? Can a person enter through and come out? come out from another door. From another door. Question mark. From another door, question mark. So dear learners, look at the question. What the question says is, how many? A garden has 7 doors. Full stop. In how many ways can a person enter through and come out from another door? How many ways can a person goes through and then comes out from another door? Assuming in your garden or in your father's house, there are 7 doors. And here you are not going to repeat. By the way, you are not going to make a repetition. I go, I come, I go, I come. No. You are supposed to enter once and then come out once. Now, how many ways will that person have gone through the 7 doors in the house is what the question is asking us to do. So you have to analyze this question seriously, and then now you'll come out with your answer. You are said a number of doors, there are 7. So meaning that n equals to 7. And then now, where is the number of times? They have not even given us here. So you only come and look at, reason out that if one enters, it means that is once. And then coming out also means once. You go once and you come out once. That means someone had to go through the door how many times? Twice, going and coming out. Coming and entering. Entering and coming out. Entering and coming out. Entering and coming out. So coming out, that means this already two times. Therefore, it means now the R will give us 2. This person entered and came out once. So it means he has passed through that door 2 times. Now, if he has passed through 2 times and the door has and the house has 7 doors, or the garden has 7 doors, then now you will come and say permutation, which is Pn base R equals to P. We have known the value of n, which is 7, and then R is given as what? As 2. It's the same as now n factorial over what? Over n minus R, close the bracket, factorial. So then now from there, dear learners, I think now there you can now be able even to solve by substituting the value of R. So we shall have 7 factorial over 7 minus 2 factorial. So this will give us 7 factorial out of what? Out of 5 factorial. So dear learners, up to that level, you will now be able to simplify. Now, when you are simplifying, it means you are going to move 7 up to where? Up to 1. So you will have 7 by 6, and then by 5, by 4, by 3, by 2, by 1. Divided by what? 5 factorial, which is 5 by 4, by 3, by 2, and then by 1. Then now you cancel. You find that 1 goes with 1, 2 goes with 2, 3 goes with 3, and 4 goes with 4. And then 5 goes with 5. So you remain with only 7 times what? Times 6, which will give us 42. Then now you come and say, therefore, p raised to 7 base 2 equals to 42 ways. So this person will have to go 42 ways to go through the 7 doors that the garden has. Now, dear learners, that is how you simply simplify or solve anything on permutation that involves problem solving. Then sometimes learners look at this expansion. You find that assuming now the number it goes to 20, will you also move up to 20 factorial? So there is also a shortest form that you can use to get that. Let me give you the shortest form. If you don't want, because learners are different, you may find that the slow learners can go with the longest step, but the whatever the quicker ones may not continue because it may consume a big space. So you may say, if I'm given 7 factorial over 5 factorial, I will move 7 up to where I get 5, then I cancel. So I will have 7 by what? By 6 by 5. And then I put there factorial. And then over what? 5 factorial. This is the shortest form. And then this factorial 5 goes with the factorial 5. You remain with what? 7 times what? Times 6, which will give you 42. So, which is the same as our answer here. So it depends. You only have to move. Even if they say maybe 10 factorial over 7 factorial, it is the same. You simply say I will move 10 until I reach 7. 10, 9, and then 8. When I reach to 7, I will say 7 factorial, then divide it by 7 factorial so that you cancel, and then you simplify. So dear learners, that is how you can easily work out in problem solving of quadratic, of permutation. Then now with these examples, learners, I believe and I hope that you have at least understood or picked something from our lesson of now. And with this, I want you to try these questions. I want to leave you with the homework exercise. So try these questions. This is homework exercise. Homework exercise. Homework exercise. The question says, question number 1 says, in how many different words? In how many different words? In how many different words of three different letters can be formed from the word Saturday. Can be formed from the word Saturday. From the word Saturday. That is number 1. Number 2. Number 2. In how many different words? In how many in how many different words in how many different digits, in how many different digits can be formed from a set of numbers can be formed from a set of open bracket we have 0, 2, 4, 6, 8. If there are three, if there are three numbers. So, dear learners, take those questions as your homework exercise. Go and try them. And with this class, we have come to the end of our lesson. And I hope that you have understood or picked something in under solving problems in permutation. Look at the question, see that is it containing the number and the terms. Then you can be able to apply the formula. With these learners, I hope we have come to the end of our lesson, and I wish you the best for your attention, and I say goodbye for now. We meet again.